So today we are talking about multiple angles. So the identities we're going to be focusing on today are for double angles. I will give you these double angle formulas on the test as well. Basically, if I have an angle that's twice as much as like a standard angle, I can split it up using these formulas. So the first few examples we have are to solve equations using this. Number one wants me to solve 2 cosine plus sine 2x. Because of that 2 in front of the x, I'm going to use the double angle formula here on the sine. So the cosine is going to stay alone for right now. And then, because this is a sine double angle, I'm going to replace it with 2 sine x cosine x. And this still equals 0. Okay, and then how would I go about solving this one? Any ideas? I can't combine like terms because this cosine is being multiplied by a 2. I mean a sine. Factor out the cosine. Just the cosine? I know, just the cosine x? 2 cosine. Okay, so what do I get when I factor that out of my first term? And out of my second term? Yep. What other question? This one? This came from me using the double angle formula. I factored it out. Remember, factoring is kind of like division, but not all the way. Okay, on this first one I want to solve, so I'm going to start off by dividing both sides by 2. This just still gives me cosine of x equals 0. Okay, where is cosine equal to 0? Remember, cosine is x. Pi halves and 3 pi halves. Does this give me an interval to have my answer in? No, so how should I write my answers? Should I write them like this? What are they missing? Right, and then I'm going to solve for sine before I write where n is any integer. So over here, this one I need to subtract 1 on both sides. Where does sine equal -1? Sine is y. 3 pi halves. I already have 3 pi halves written down, right? So I don't need to write it again. So then I'm just going to write where n is any integer. Okay, so number 3. It wants me to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. It gives me that cosine is 5 over 13, and it tells me it's between 3 pi halves and 2 pi. Which quadrant is this in? 4. Okay, and then how do I label my triangle? Diana, it told me it was in between 3 pi halves and 2 pi. In between 3 pi halves and 2 pi seconds. Okay. Okay, what number goes here? Negative 12 because it's going down. 12 because it is a Pythagorean triple. Okay. So then I just need to use my identities from the front. Sine of 2 theta is 2 sine theta cosine theta. What? Why are we doing what? Why did I draw the triangle, or why did I write sine 2 theta equals? Because it wants me to find sine of 2 theta. So I just wrote the equation from the front. I haven't done any math yet.
Oh, so you would like plug it in?
Yeah.
And are you going to do that for all of them?
Yeah, I'm going to do that for all of them.
Okay.
Yes, Diana? Yes. What first part? The triangle? This is literally me taking the formula from the front. I haven't plugged anything in yet. That's the thing. I was just copying it from the front so I had it on the same side. Because it asked me to find sine of 2 theta. Yes, and I can only do one at a time. Yes! Okay, so now I'm going to plug in. What is the value of sine on this triangle? And the value of cosine? Cosine? Okay, then I want to go ahead and multiply. 2 times negative 12 is negative 24 times 5. Nope. Negative 24 times 5. Negative 120. 13 times 13. $169. Are you asking me how numbers multiply?
No, I'm asking
13 times 13. No, because remember the 2 is over a secret 1. What was your question?
Oh, if it were able to simplify, would we simplify?
Yeah, and if I could simplify it, I would, but this one doesn't. That's it for the sine of 2 theta. I still need to do cosine 2 theta and tangent 2 theta. Okay, so my cosine 2 theta formula was cosine squared minus sine squared. So I am going to plug into those two formulas. I am going to write my fraction and then square it. So what was cosine? And this whole fraction is getting squared. Sine was and that whole thing gets squared. When I'm squaring fractions, I square the numerator and denominator separately. So 5 squared is 13 squared. Negative 12 squared. Positive 144. So remember, I have two negatives multiplying by each other. And I still have this negative from the outside. 13 squared. Okay. 25 minus 144. And it's still over 169. Questions on cosine? Okay, so for tangent, this is 2 tangent theta over 1 minus tangent squared theta. So I want to go ahead and plug into this. What is tangent of theta? Okay, so on my numerator, I want to multiply. What's 2 times negative 12? And the 5 is going to stay alone for now. On the denominator, what is negative 12 squared? Okay, what do you want me to do next? I have whole numbers and fractions. I want to make them all fractions before I multiply by the reciprocal. So I'm going to take this lid and multiply by 25 over 25. So my numerator stays the same. Okay, so my numerator again is going to stay the same for this next step. What do I get on the denominator? Over Okay, now I can multiply by the reciprocal. So because I have a fraction divided by a fraction, I take the denominator fraction and flip it. Yeah. So that gives me a 1 on the bottom and a 5 on the top. Okay, so negative 24 times 5. Right, 1 times negative 119. Negative 119. Can this simplify anymore? I can make it a positive.